Hey everyone, welcome back. In this video, we're going to learn how to manufacture our container base that we made in a previous video. All right, so when you're ready, go ahead and open up your container base file. All right, come on over to design and come on down to manufacture. And the first thing we want to do is start a new setup. So come on up to setup, select new setup, and we need to set up our work coordinate system. All right, and so if we're facing our part here, okay, pretend our part here is in our machine, in our vise. All right, we always select the back left corner here most of the time. Okay, and we want our positive X going to our right, and we want our positive Y going away from us. So we need to change some things here. So let's come on over to, model orientation and select X and Y axes. All right, so I'm going to make that. So it's saying, hey, select your X axis here. So let's come on over here. I want that my X axis, right? And my Y, I want that to be my Y, okay? And that's looking better, okay? But now let's come back to model box point, okay? And let's come back to stock box point, excuse me, and select that back left corner, okay? And now we're good. Our positive Y is pointing away from us. Our positive X is pointing to the right, and our positive Z is pointing upwards. Okay, now let's come on over and set up our stock size or our material size. So our stock size, select fixed size box, and our width is going to be 3 inches centered, and our depth is going to be 3 inches centered. Okay, but for our Z now, it's going to be 1.25 inches. Okay, and we are going to offset it from the top of our part, positive Z, a distance of 0.02 inches, okay? And that 0.02 inches, remember that thickness there, okay? So select OK, and that 0.02 inches is going to be how much we're going to face off on the top of our part, okay? So we have our setup all completed. We're now ready to start our first operation. And don't forget to save, okay? But I'm going to go ahead and move on here. So let's go ahead and come 2D, and we're going to start our first operation, toolpath, and it's going to be a facing operation, okay? And let's come on over here and select our tool, as we did with our lid here. We're going to do container tool library, and we're going to select our 2.5 inch face mill. Let's go ahead and select that guy. Make sure coolant's at the flood. We will do a spindle speed of 4,000, okay, and a cutting feed rate of 20. Okay, all of our other default values are fine. Let's go to geometry, and we're going to select that top piece here. All right, and let's see here. Our heights tab is fine. Our passes tab. So for our pass extension, let's set that to 1 inch. So our tool path extends 1 inch out past our part. And for stock offset, we're going to sort of widen our tool path so we get the entire surface. We're going to go with a 1/4 inch here, 0.25 inches, okay? And that will do it for this tool path. Go ahead and select OK, okay? And you should end up with the following tool path. All right, so let's go ahead now and start our second toolpath operation. We're going to come up here to 2D, and we're going to select 2D adaptive clearing. And let's go ahead now and change our tool. So we're not using a face mill anymore, but we are using a 3/8 flat end mill. So go to your container tool library, select your 3/8 3-flute carbide end mill, and hit select. Set your coolant to flood, and it should always be flood in case I forget. All right, and your spindle speed here in this time is going to be 5,000. Okay, and our cutting feed rate in this case will go ahead and be 20 inches. All of our other default values are fine. Let's go to our geometry tab. Okay, and the first thing we want to do is remove material around the lip of our container here. So I'm going to click there, and then I want to remove material along the bottom of our container. So I'm going to click there, okay? And then for our heights tab, we're fine. For our passes tab now. So what we want to do is set our optimal load to 0.1 inches, okay? And make sure stock to leave is checked because this is a roughing operation and we want to leave behind some stock, okay? So we're going to leave behind 0.02 inches in the radial stock and we're going to leave 0.02 inches in the axial stock. Okay, so radial stock, okay, think of radial as the stock we're leaving along our floor. Axial stock, think of this, the stock we're leaving along all the walls of our container. Okay, everything else looks good. Let's go ahead and select OK. Now let's go ahead and simulate this guy real quick. Okay, so let's get play, and if we did everything correctly, it's going to come down and it's going to remove the material around the lip of our container first, and then it's going to come down and remove material along the sides of our container. So let's hit play and see what it does here. Yep, so it's going to come around our lip and remove some material. Okay, and then after it removes all that material around our lip, it should come down and remove the material along the walls of our container, just like we did here. Okay, looks good. I'm going to go ahead and close it. Okay. All right, so now we need to remove the material in our pocket or the inside of our container here. So we're going to come on up to 2D and we're going to do a 2D pocket. Okay, we're going to use the same tool, 3/8 flat end mill. Make sure your coolant is set to flood because we're going to be removing a lot of chips, and our coolant is going to push out all those chips as we mill and machine the inside of this pocket. Okay. For our spindle speed, let's go with 5,000, a cutting feed rate of 20 like we did last time. Our ramp feed rate, we're going to go with 10, okay, because our ramp feed rate, remember, and our plunge feed rate, control those speeds as the tool is entering the pocket. Okay. Over here for geometry, we're going to select the bottom contour of our pocket. Okay, our heights tab is fine. Okay, our stock to leave 0.02, radial and axial, same as before. However, for this time, our maximum step over is going to be, once again, 0.1 inches. All right, and there's a couple things I want you to do now. I want you to check feed optimization because this is a pretty deep pocket. What that's going to do is it's going to slow down our tool in these corners, because when our tool's in the corners, there's more of the tool is engaged with our part, which creates more friction, which creates more heat. So let's slow it down a little bit by checking feed optimization and make sure the only inner corners box is checked. So it's going to slow it down a little bit here by 5 inches per minute. Okay, that'll do it for this operation. Go ahead and select OK. All right, so when you're done, I would like you to go ahead and simulate this guy and make sure everything looks good. Okay. But I'm going to go ahead now and move on to our next toolpath operation. Okay, so our roughing operations are now done. Now let's go ahead and start our 2D contour finishing passes. So let's come on up here to 2D again, and we're going to do a 2D contour. We're going to use the same tool. Make sure your coolant is set to flood. Only this time we're going to slow things down a bit. We're going to go with 3,000 RPMs. Okay, and a feed rate of 15 inches per minute. Okay, all of our other default values are fine. For our geometry tab now, we're going to come on over here and we want to remove the material, okay, along the sides of our container. So we're going to click here and we want to remove the material along the lip of our container. We want to click here, okay. And so our heights tab is fine. For our passes tab, okay, make sure you do not check stock to leave. We want to remove all that stock that we left behind in our roughing operation. Okay, everything else looks good. Our finishing feed rate is 50. Let's go ahead and select OK. Okay, once again, please simulate this. I'm going to move on to our next toolpath operation. So we need to do one more finishing pass inside of our pocket here. All right, so let's come on up to 2D and we're going to do yet another 2D contour this time. Okay, so our settings are good. 3/8 flat end mill. Our coolant set to flood. Our spindle speed is 3,000. Okay, our cutting feed rate is 15. Our ramp feed rate, well, we don't need to worry about those since this is a 2D contour. Let's come on over to geometry now, and we're going to select once again our pocket here. All right, so the pocket perimeter contour. And so for our heights tab is good. Our passes tab now, all right, we need to do something here. We need to check multiple finishing passes. We're going to change our step over now to 0.3. So we're going to have a larger step over, right? But that's okay because we're only cutting 0.02 inches of thickness of material. So we can increase our step over, okay? And we're going to do not 2 finishing passes, but to get the entire floor, okay, we're going to do 4. All right. Everything else should look good. Okay. Let's go ahead and select OK. Okay. And there is our finishing passes. And remember, it's removing that 0.02 inches of stock along the floor and along the walls. Okay. And which will give us a nice, smooth, high tolerance, high accuracy part here. Okay. All right, and finally, let's go simulate this guy, but I'm going to just call this setup 1 because this is our first setup. Okay. And now let's go ahead and click on it and simulate it. Okay. And when you're done, your stats, okay, you should have roughly a machining time of 11 minutes and 29 seconds. Okay. So let's come back over to display, check stock, and I want you to simulate everything here. Okay. And fool around with some of these. If you want to change the colorization and some of these other things, go for it and see what happens. But for now, let's go ahead and simulate this guy. I'm going to increase the speed here, so we're cooking through it. Okay, there's our 2D adaptive. Here comes our 2D pocket. Okay, our 2D contour paths. Okay, and that's it. All right, hopefully you have something that looks like this, but we're not done yet, right? That's our first setup. What about this material here, our base? We need to remove that material from our container, the base here. So now that we're done with our first setup, we need to do a second setup and remove the material along the base, the bottom of our container here. We call this the hat portion here. All right, I'm going to select close. That'll do it for the first setup. All right, now let's go ahead and start our second setup. All right, so for our second setup, now let's come on up and we're going to start a new design. All right, I'm going to save this now as, we're going to save it as base setup 2. So for our second setup, all right, and let's go ahead and select save. And it's important to realize that a lot of the times when you're doing a second setup, you could just come on up here and do another setup. Okay, but we're not going to do that. Okay, we are going to start a new file and do sort of a custom second setup here. All right, so hopefully you have this Kurt Weiss container file already in your data panel. Okay, if not, download it, get it into Fusion 360, and then right click on it, and let's go to Insert into Current Design. Okay, I'm going to rotate it so it's upright here. Now come on over to your base and right click Insert into Current Design. All right, I'm going to move it into position here so it's kind of sitting above my vise, and I want to rotate it so that my first setup is going to sort of pop into these soft jaws here. Okay, so let's go ahead now and flip that guy over. I'm going to move it slightly over here. Okay, and that's a pretty good position. Let's go ahead and select OK. All right, now I'm going to zoom in here because you see the lip of our container? The lip of our container needs to be in this, along this wall here. Okay, so it needs to be touching the bottom of our soft jaws. Okay, remember, these soft jaws are custom machined fixture to hold our container in place. All right, and so what I'm going to do now is I'm going to rotate my part around here, and I want to do an assembly. I'm going to come on up and we're going to do a rigid constraint, and I want to think now where, if I click here like we did last time, this point right here, where would I want to click? What's the point I want to match up with on my part here, on my container? Okay, and I want it to be right, let's move it around, right there. Okay, and hit OK. And you can see, all right, you can see now that it's our lip of our container is sitting in the bottom of our soft jaws. Okay, sitting nice and snug. Okay, And same thing on this side. So we're good. If it doesn't look like that, repeat this process until you get it. All right. Okay. So we have our part now in our soft jaws, in our vise, and we're ready to start our second setup. Okay. Let me click right there. I'm going to zoom in a bit. Okay. So the first thing we want to do is remove that material that's sort of left behind, okay, the hat portion, okay, of our stock material. So what we want to do now is start manufacturing this guy. So come on over to design and select manufacture, and don't forget to save, please. Once you got everything, just remember to save frequently. Okay, so now that we're in manufacture, let's start a new setup first. Same thing we want to do is always start a new setup first. All right, so when we go to use our G54 work coordinate system setup, we're going to use this hole in our soft jaw. Okay, so what we want to go ahead now is for our orientation, let's go ahead and select our Z-axis and X-axis. Okay, and for our origin now, let's go ahead now and select selected point. And I'm going to select right there. Okay, and if you notice, shoot, our X, Y, and Z are not correct, but that's okay. But for our model real quick, let's go ahead and select on our actual part, select that guy. So for our Z-axis, let's change it. We want that to go up, right? That our Z-axis looks good now, but now our Y-axis is like, oh shoot, doesn't look so good. Okay, so now let's go ahead and select our X-axis here, and our X-axis is this direction right here. And there we go. We're good to go. So imagine your part is in the vise here and you're facing it. Okay. And I say this a lot because it's important to realize that if you don't have your work coordinate system set up correctly, you could have crashes and other bad things will occur. So make sure you have your work coordinate system set up correctly. All right. So for our work coordinate system, our G54 here, all right, make sure that positive X is pointing to the right, positive Y is pointing away from us, and positive Z is pointing upward here. Okay, now let's go set up our stock size. Go to fixed size box, and same as last time, we got a 3 inches centered, 3 inches centered. Okay, however, this time our height is 1.23. Okay, and you're like, well, why not 1.25 like last time, right? Well, remember, we shaved off 0.02 inches with our first facing operation. Okay, so 0.02, 1.25 minus 0.02 gives us 1.23. Okay, and we are going to not center it. We're going to offset it from negative Z, a distance of 0. Okay, and then hit OK. All right, and now remember, it's this top portion of material we need to remove, right? Okay. So I'm going to flip it around here. So now let's go ahead and start removing that material. Okay. So what we want to do now is just, you probably guessed, a facing operation. All right, so we're going to come to facing operation. We're going to select our tool, come over to the container tool library, select our 2.5 inch face mill. Go ahead and hit select. Make sure your coolant's set to flood. Okay, our spindle speed is 4,000 and our cutting feed rate is 20. Okay, and our geometry, we're going to select the top of our part because we want to cut all the way down to the surface here of our part, or it's actually the bottom of our part, but in this case, since it's flipped upside down, we'll call it the surface of our part. Okay, our heights tab is good. Our passes tab now, okay, we are going to extend our pass so that it goes 1 inch past our part. Okay, and our stock offset, we're going to do 0.25 inches, so it's going to sort of widen our tool path a bit here. Okay, and then we're going to check multiple depths because we have a big chunk of material we want to remove, and we don't want to remove it in one pass because that would probably cause our tool to crash. So it's very important you check multiple depths here, and you set our multiple depths to 0.05. Okay, and we're good here, so let's go ahead and check OK. All right, and if you look at it, Okay, this distance right here, this is our 0.05, 0.05, 0.05, 0.05 until we get to the surface of our part here. Okay. All right, so our facing operation is done. Problem is, our facing operation usually leaves behind a very jagged edge, and we don't want that. I don't want you guys to get cut, or anybody else handling your container. I don't want them to get cut. So we got to do a deburring operation or a 2D contour. So let's come on up and do our last operation for this part. We're going to do a 2D contour. Let's come over here and change our tool. Okay, and we want to select our 1/4 inch chamfer mill. Let's go ahead and hit select. All right, and set the coolant to flood, spindle speed. We're going to do 3,000. Okay, and cutting feed rate, we're going to go with 15. Okay, and all of these other default values are fine. Let's come on over here now to geometry, and we're going to just select the outer edge, top of our container here. All right, our heights tab is good. Our passes tab now, we want to set our chamfer width. We're essentially making a very, very, very small chamfer here, 0.01 chamfer with our tool. Okay, and our chamfer tip offset, okay, we want to set that now to 0.02. That'll move the tip of our tool, of our chamfer tool, just down below the edge of the part a little bit. Okay, everything else here looks good. However, in our linking tab now, I want you to do a lead-in, okay, a horizontal lead-in radius distance of 0.5. Okay, this is going to create a more gradual entry to our tool path. Okay, and the reason is because sometimes from our previous operation we have pieces of jagged metal sticking off that are left behind, and this gives us more time to react to and hit the stop button in case something is wrong. Okay, so let's go ahead now and hit OK. And you see this, it's going to come in, simulate it real quick. Okay, and it's going to come in gradually here, and it's going to kind of exit gradually too. Okay. All right, and that is it for our second setup now. So what I want you to do now is to go ahead and simulate this guy. Check your stock. Make sure we remove that top piece of material, and you did your 2D contour deburring operation here at the end, and check your stats. If you did everything right, your machining time should be around 1 minute. Okay, pretty quick operation. All right, go ahead and select close, but please run your simulation, double check to make sure everything looks correct. Okay, and when you're all finished, everything looks good. Okay, don't forget to save. Okay, and remember, when you're ready to post-process, go to Setup, select Post-Process, and you're ready to roll. Save it to a USB thumb drive, and we'll go start making your part. All right. I hope you guys learned something. Thank you so much for watching, and we'll see you next time.